Hello everyone, we have already discussed the concept of probability. Now we are going to discuss conditional probability, independent events and Bernoulli trials. So according to the conditional probability, suppose E is an event in a sample space capital S with probability of E greater than 0. That means probability of E is non-negative. The probability that an event A occurs once E has occurred, or specifically the conditional probability of A given E, is equals to probability of A intersection E divided by probability of E. Suppose S is an equiprobable space and A and E are events, then probability of A given E would be number of elements in A intersection E divided by number of elements in E. That is cardinality of set A intersection E divided by cardinality of set E. So here is an example. A pair of fair dice is tossed. The sample space S consists of the 36 ordered pairs AB. Because each dice have 6 numbers 1 to 6. So if we toss 2 dice, then the total pairs would be 36, that is 6 into 6, which is 6 square, where A and B can be any of the integers from 1 to 6. Thus the probability of any point or any ordered pair would be 1 by 36. Find the probability that one of the dice is 2 if the sum is 6. That is, find probability of A given E. So here set E is sum is 6 and A is 2 appears on at least one dice. Now E consists of 5 elements, that is sum is 6. So we have total 5 choices, that is 1 5 5 1 2 4 4 2 and 3 3. And 2 comma 4 and 4 comma 2 also belongs to capital A. So A intersection is 2 comma 4 and 4 comma 2. Total 2 outcomes. So probability of A given E would be 2 by 5. On the other hand, A consists of 11 elements, that is for set A we have total 11 choices, that is one of the dice is 2. So 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 6, 1 2, 3 2, 4 2, 5 2 and 6 2. These are the total outcomes for the set A. So the probability of A would be 11 by 36, that is total sample space 36. We also have independent events. So events A and B in a probability space capital S are said to be independent if the occurrence of one of them does not influence the occurrence of the other. So more specifically, B is independent of A if probability of B is the same as probability of B given A. That means A is not influencing the B. Now substituting probability of B for probability of B given A, we get probability of A intersection B is probability of A into probability of B. So here is an example. A fair coin is tossed 3 times yielding the equiprobable space. Then we will get total 8 outcomes. So we have events. Let's A equals to first toss is head. Then we have these outcomes, total 4 outcomes. And B is the event, second toss is head. Then again we have total 4 outcomes. And C is the event, exactly 2 heads in a row. So we have total 2 outcomes. So here A and B are independent because A is the event, first toss is head, and B is the event, second toss is head. So they are independent to each other. So let's find the relation between A and C and B and C. So probability of A is, because A have total 4 outcomes. So favorable cases are 4 and total sample space is S, that is 8 outcomes. So 4 by 8, which is 1 by 2. Again probability of B is 1 by 2 and probability of C is 2 by 8, that is 1 by 4. And we can find probability of A intersection B from these sets. So this is 1 by 4 and probability of A intersection C is 1 by 8 and probability of B intersection C is 1 by 4. So now by definition, probability of A intersection B equals to probability of A into probability of B if A and B are two independent events. So which is equals to 1 by 4, and here this is 1 by 4. So you can verify that these two events are independent. Again we calculate probability of A into probability of C, which is equals to 1 by 8, 1 by 2 into 1 by 4, which is 1 by 8, and which is equals to probability of A intersection C. Probability of A intersection C. This is 1 by 8. So A and C are also independent events. If we calculate probability of B into probability of C, 1 by 2 into 1 by 4, which is 1 by 8, and here probability of B intersection C is 1 by 4. So these two are not equivalent, so B and C are not independent events. B and C are dependent events. We have repeated trials with two outcomes, that is called Bernoulli trials. So if we have experiment like we flip a coin, so then we have two outcomes, that is head and tails, and these two events are independent. These two outcomes are independent to each other. So then the probability of exactly k success in a binomial experiment of n trials of probability p success is given by this formula. Probability of k would be this. So this is combination. This is also called binomial coefficient pk into qn minus k. So here is an example, like a fair coin is tossed 6 times, call heads a success. So this is the binomial experiment with n equals to 6. So we have n equals to 6 and probability p would be 1 by 2. To get the head, probability would be 1 by 2, and to get the tail, probability would be 1 by 2 also. So q equals to 1 by 2 also. So the probability that exactly 2 head occurs, that is k equals to 2, is, by this formula we can get 15 by 64, that is 0.23. And the probability of getting at least 4 heads, that is getting at least 4 heads, that means k equals to 4, 5 or 6. So we can calculate probability of 4 heads plus probability of 5 heads plus probability of 6 heads. So this can be calculated by this formula, and then we get 0.34 value.